welcome to V Chemistry Hub. I am Venu Madhavi. In this video, I will discuss the basic concepts of chemistry. Science can be viewed as a continuing human effort to systemize knowledge for describing and understanding nature. We have learned from our childhood that curd formation from milk, formation of vinegar from sugarcane juice on keeping for prolonged time, and resting of iron are some of the examples of changes which we come across many times in our daily life. So for the sake of convenience, science is subdivided into various disciplines such as chemistry, physics, biology, geology and so on. And also the branch of science that studies the preparation, properties, structure and reactions of material substances is called chemistry. And also chemistry is the study of matter and its changes from one substance to another. And chemistry is the center to all sciences and overlap with physics, biology, geology and astronomy also. Chemistry deals with the study of elements, that is atoms, molecules, compounds, ions and so on, and their chemical compositions, characteristics, structure and reactions also. And also chemistry studies the chemical bonding between elements, atoms and molecules. Okay, well, chemistry is the science that investigates and explains the structure and properties of matter. What is matter? Matter is the stuff that is all around us. The metals, the plastics, mobiles, laptops and papers, books, glass items, liquids and the air we are breathing and the material that make up our body. All this comes under matter. And the more formal definition of matter is anything that takes up space and has mass is known as matter. Okay, now coming to the importance of chemistry. Chemistry plays an important central role in science and it is often intertwined with other branches of sciences also. The principles of chemistry are applicable in diverse areas such as weather patterns, functioning of brain and operation of a computer, production in chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergents, metals, alloys and including new materials also. And also chemistry contributes in a big way to the national economy and it also plays an important role in meeting human needs for food, healthcare, products and other materials aimed at improving the quality of life. This is exemplified by the large-scale production of a variety of fertilizers, improved variety of pesticides and insecticides. Chemistry also provides the methods for isolation of living-saving drugs from natural sources and makes possible synthesis of such drugs. Some of these drugs are cisplatin and taxol. These drugs are very effective in cancer therapy. And the drug AZT is used for helping AIDS patients also. And in recent years, chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. The safer alternatives to environmental hazardous refrigerants like CFC, chlorofluorocarbons, which are responsible for ozone depletion in stratosphere, that have been successfully synthesized. So, to understand the basic concepts of chemistry, let us begin with the concept of matter. Okay, let us start with the nature of matter. You are already familiar with the term matter from our schooling also. Anything which has mass and occupies space is called matter. Everything around us, for example, book, pen, pencil, water, living things, all this comes under which are composed of matter. You know that they have mass and they occupy some space. So let us recall the characteristics of the states of matter which we learned in our previous classes. States of matter. You are aware that matter can exist in three physical states. Those are solids, liquids and gases. Let's discuss about solids. Solid state, the particles are held very close to each other in solids and in orderly fashion and it is not much freedom of movement. And liquids, In liquids, the particles are close to each other but they can move around. However, in gases, the particles are far apart as compared to those present in solids or liquid states. And their movement is easy and fast also. Because of such arrangement of particles, different states of matter exhibit the following characteristics. So, solids have definite shape and volume. Okay, and liquids have only a definite volume but not have a definite shape. They take the shape of the container in which they are placed. Gases have neither definite volume nor definite shape. They completely occupy the space in which the container is placed, which they are placed. Okay. These three states of matter are interconvertible by changing the conditions of temperature and pressure. So we can convert solid to liquid and liquid to gases also. Like on heating a solid usually changes to liquid, and the liquid on further heating changes to gas in the form of a vapor. In the reverse process, a gas on cooling liquefies to a liquid and the liquid on further cooling freezes to solid. Okay. Now coming to the classification of matter. At the macroscopic or bulk level, matter can be classified as a mixture or a pure substance. What is mixture? A mixture contains particles of two or more pure substances which may be present in any ratio. Hence, their composition is variable. Pure substances forming mixture are called its components. Many of the substances present around you are mixtures. For example, sugar solution in a water, air, tea, coffee, etc. all are comes under mixture. A mixture may be a homogeneous or heterogeneous. So, in homogeneous mixture, the components completely mix with each other. This means particles of components of the mixture are uniformly distributed throughout the bulk of the mixture, and its composition is uniform throughout the solution. For example, consider sugar solution. Sugar solution and air are the examples of homogeneous mixture. And in contrast to this, in heterogeneous mixture, the composition is not uniform throughout and sometimes different components are visible. For example, mixture of salt and sugar in a pack, and grains and pulses along with some stones. These are the examples of common examples of a heterogeneous mixture. So you can think of many more examples of mixtures which we come across in our daily life also. And it is worthwhile to mention here that the components of a mixture can be separated by using physical methods such as simple hand picking, filtration, crystallization, distillation, and so on. Methods are there for separation of a mixture. Pure substances have characteristics different from mixtures. Constituent particles of pure substances have fixed composition. For example, copper, silver, gold, water and glucose are some of the examples of pure substances. Glucose contains carbon, hydrogen and oxygen in a fixed ratio, and its particles are of same composition. Hence, like all other pure substances, glucose has a fixed composition. Also, its constituents carbon, hydrogen and oxygen cannot be separated by simple physical methods. Okay. Pure substances can further classified into elements and compounds. What are elements? Elements are the particles. The particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. Examples: sodium, copper, silver, hydrogen, oxygen. All these examples of elements. They're all atoms are of one type. However, the atoms of different elements are different in nature. Some elements such as sodium or copper contains atoms as their constituent particles, whereas in some other the constituent particles are molecules which they are formed by two or more atoms. For example, hydrogen, nitrogen and oxygen. These gases consist of molecules in which two atoms combine to give their respective molecules. Okay, now coming to compounds. when two or more atoms of different elements combine together in a definite ratio, the molecules of a compound is obtained. Moreover, the constituents of a compound cannot be separated into similar substances, simpler substances or similar substances by physical methods. This can be separated by chemical methods. Examples of some compounds are water, ammonia, carbon dioxide, sugars, and so on. Okay, let us consider the molecule of water and carbon dioxide. Water molecule comprises two hydrogen atoms and one oxygen atom. Similarly, a molecule of carbon dioxide contains two oxygen atoms combined with one carbon atom. Okay, thus the atom of different elements are present in a compound in a fixed and definite ratio. Okay, and this ratio is characteristic of a particular compound. Also, the properties of a compound are different from those of its constituent elements. Okay, for example, hydrogen and oxygen are gases, whereas the compound formed by their combination, that is water, which is a liquid. It is interesting to note that hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is used as a fire extinguisher. Let us go through the properties of matter and their measurements. Physical and chemical properties. Okay, every substance has unique or characteristic property. These properties can be classified into two categories, physical and chemical. Okay, now coming to physical properties such as color, odor, melting point, boiling point, density, and okay, all this comes under physical properties. Now coming to chemical properties like composition, combustibility, reactivity with acids and bases. Okay, and physical properties can be measured or observed without changing the identity or the composition of the substance. The measurement or observation of chemical properties require a chemical change to occur. Okay, the measurement of physical properties does not require occurrence of a chemical change. Okay, the examples of chemical properties are characteristic reactions of different substances. These include acidity or basicity, combustibility, and so on. Chemists describe, interpret, and predict the behavior of substances on the basis of knowledge of their physical and chemical properties, which are determined by careful measurement and experimentation. In the following section, we will learn about the measurement of physical properties. The quantitative measurement of property is required for scientific investigation. Many properties of matter such as length, area, volume, and so on are quantitative in nature. Any quantitative observation or measurement is represented by number followed by units in which it is measured. So, the international system of unit is used for measuring. It also denoted as SI. So, the SI system has 7 base units. These units pertain to the 7 fundamental scientific quantities. They are length, mass, time, electric current, thermodynamics, temperature, and amount of substance and luminous intensity. Okay, the other physical quantities such as speed, volume, density, and so on. These can be derived from these quantities. Okay, let us discuss about mass, weight, and volume. What is the mass of the substance? Mass of the substance is the amount of matter in it, while weight is the force exerted by gravity on an object. The mass of the substance is constant, whereas its weight may vary from one place to another due to change in its gravity. You should be careful in using the terms mass and weight. Okay. The mass of a substance can be determined accurately in the laboratory by using an analytical balance, and the SI unit of mass is kilogram. However, its fraction named as gram. 1 kg is equals to 1000 grams. In terms of grams is used in laboratories due to the smaller amount of chemicals are used in chemical reaction. Okay. Now coming to volume. Volume is the amount of space occupied by a substance. It has the units of length cube. So in SI system, volume has unit of m3, m power 3. What is volume? Volume is the amount of space occupied by a substance. It has the unit of length cube. So in SI system, volume has unit of m cube. But in laboratories, small volumes are used. Hence, volume is often denoted in centimeter cube or dm cube units. A common unit, liter, which is not an SI unit, it is used for measurement of volume of liquids. So, 1 liter equals to 1000 ml or 1000 centimeter cube. In the laboratory, the volume of liquid or solution can be measured by a graduated pipette or cylinder or burette. Okay, a volumetric flask is used to prepare a known volume of a solution. Now coming to density. The two properties mass and volume discussed above are related to density. So density is equals to mass by volume. Density of a substance is its amount of mass per unit volume. So the SI unit of density can be obtained as SI unit of mass by SI unit of volume. So the density of a substance tells us about how closely its particles are packed. If density is more, it means the particles are more closely packed. So density is expressed in gram per centimeter cube, whereas mass is expressed in gram and volume is expressed in centimeter cube. Now let us discuss about temperature. There are three common scales to measure temperature: degree Celsius, degree Fahrenheit and Kelvin. Here Kelvin is the SI unit. Generally, the thermometer with Celsius scale are calibrated from 0 to 100 degrees, where these two temperatures are the freezing point and boiling point of water. 0 is the freezing point of water and 100 is the boiling point of water. The Fahrenheit scale is represented between 32 degrees to 212 degrees. The temperature on two scales are related to each other. Fahrenheit equals to 9 by 5 into centigrade plus 32. The Kelvin scale is related to Celsius scale as Kelvin equals to centigrade plus 273.15. Human body temperature in centigrade is 37 degrees centigrade and in Fahrenheit is 98.6 centigrade Fahrenheit. Since the measurements involve recording of data which are always associated with a certain amount of uncertainty. Okay, the proper handling of data obtained by measuring the quantities is very important. The measurement of quantities in chemistry are spread over a wide range of 10 to 31 to 10 plus 23. Hence, a convenient system of expressing the number in scientific notation is used. The uncertainty is taken care by specifying the number of significant figures in which the observation are reported. The dimensional analysis helps to express the measured quantities in different systems of unit. Hence, it is possible to interconvert the results from one system of units to another system of units. Now coming to the law of chemical combinations. The combination of elements to form compound is governed by the 5 basic laws. Those are law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lucas law and law of gaseous volume and Avogadro law. Now coming to law of conservation of mass. The experimental study says that in all physical and chemical changes, there is no net change in mass during the process. So, law of conservation of mass states that matter can be neither created nor destroyed. Okay. Now coming to law of definite proportions. This law was given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. He worked with two samples of cupric carbonate, one of which is natural and the other one is synthetic one. He found that the composition of elements present in it was same for both the samples. Thus, he concluded that irrespective of the source, a given compound always contains the same elements. Okay. The same elements combined together in the same proportion by mass. The validity of this law has been confirmed by various experiments. It is sometimes also referred to as a law of definite proportions or definite composition. Now coming to the third law, law of multiple proportion. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combined with a fixed mass of the other element are in the ratio of small whole number. For example, hydrogen combines with oxygen to form two compounds. Those are water and hydrogen peroxide. Here, hydrogen 2 grams and oxygen 16 grams are taken and it gives water 18 grams. Similarly, 2 grams of hydrogens and 32 grams of oxygen, it gives hydrogen peroxide 34 grams. Here, the mass of oxygen in two reactions 16 grams and 32 grams are taken, which combined with the fixed mass of hydrogen 2 grams. So the simple ratio of them is 16:32 or 1:2. And the fourth law is Gay-Lucas law of a gaseous volumes. Okay, this law was given by Gay-Lucas in 1808. He observed that when gases combine or produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. Thus, 100 ml of hydrogen combined with 50 ml of oxygen, it gives 100 ml of water vapor. Okay. Similarly, 100 ml of hydrogen with 50 ml of oxygen, it gives 100 ml of water. Thus, the volume of hydrogen and oxygen which contains that is 100 ml and 50 ml have a simple ratio of 1:2. Okay. Now coming to the last law of Avogadro law. Avogadro proposed that equal volume of all gases at same temperature and pressure should contain equal number of molecules. Avogadro made a distinction between atoms and molecules, which is quite understandable in present times. If we consider again the reaction of hydrogen and oxygen to produce water, we see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Here, each box contains equal number of molecules. In fact, Avogadro could explain the above result by considering the molecules to be a polyatomic. If hydrogen and oxygen were considered as diatomic as recognized, now then the above result are easily understandable. However, Dalton and others believed at the time that atoms of the same kind cannot combine and molecules of oxygen or hydrogen containing two atoms did not exist. As discussed, the combination of different atoms is governed by basic law of combination, this being the law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lucas law of gaseous volumes and Avogadro law. All these laws led to the Dalton atomic theory, which states that atoms are building blocks of matter. Now let us discuss about the Dalton's atomic theory. It states that matter consists of indivisible atoms and all atoms of a given element have identical properties including identical mass, and atoms of different elements which will be differ in mass. And the next point is compounds are formed when atoms of different elements combine in a fixed ratio, and chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Thank you. Thanks for watching. The continuation of this session will be uploaded in the next video.